Exadata is very complex system, and there are many components in Exadata. Basically, you have servers, two types of servers: database servers and storage servers. Then switches, InfiniBand switch and Ethernet switch, and depending on the model, KVM switch also. Then you have power distribution units, and we have many software installed on the servers. On database servers, we have grid infrastructure, we have Oracle database, and databases, one or multiple databases, could be single instance database or rack database. And on the storage servers, we have Exadata storage server software installed. Okay, plus operating system on both the servers. Now, the question is, how do you monitor all these components? Okay, monitoring is one of the core admin tasks, right? If you cannot monitor, you cannot control. That is as simple as that. So how do you monitor all these components? So traditionally, if you want to monitor your databases, database servers, we use some third-party tools or Oracle tools like Oracle Enterprise Manager, or scripts, okay, shell or Perl or Python or whatever, okay, shell scripts. Basically, shell script is another mechanism. If you don't have tools, DBAs, admins depend on the scripts. On Exadata also, you can continue the same model, okay. But let us see what are the specific mechanisms to monitor Exadata system. Basically, you have Oracle Enterprise Manager, which is the single tool to monitor every component of Exadata. Oracle Enterprise Manager Cloud Control. So, using Oracle Enterprise Manager Cloud Control, you can monitor complete Exadata platform, every component of Exadata system, your servers, your switches, your power distribution units, okay, your databases, your operating systems, everything that is part of Exadata. But you know, Enterprise Manager is a separate license. You have to purchase, you have to install, you have to configure. And one good thing about Enterprise Manager is it is not a new tool to DBA. It's not a new learning to DBA. So that means you can invest your existing skills in monitoring Exadata. Okay, you just need to extend Enterprise Manager usage to monitor Exadata. So if you are familiar with Enterprise Manager, you can self-learn. Just you need to add the targets related to Exadata and go to their screens and monitor them. That's the way. Only thing is, Enterprise Manager is separate license. So many customers may not be already using Enterprise Manager. Some customers may be using Enterprise Manager. In that case, once Exadata is installed, you can configure your Exadata system to be monitored from Enterprise Manager. That can be done during initial installation of Exadata. So during initial installation itself, it will ask you, okay, the cloud control details, Enterprise Manager cloud control details, using which this system has to be monitored. So you can enter all those details during initial installation and the configuration itself. Or if Enterprise Manager is not installed, later you can install and deploy the agent software on Exadata and configure all the targets, and then onwards you can start monitoring Exadata. So anyway is fine. That is brief about Enterprise Manager Cloud Control. Now, what if I don't have Enterprise Manager Cloud Control? I don't want to use it. I don't have that license and I don't want to buy also. So is there any other alternative? How do I monitor? Now, that is where inbuilt monitoring comes into picture. Exadata storage server has, sorry, 1 minute, let me have some. So Exadata storage server has inbuilt metrics, alerts. So alert and metric repository is inbuilt into Exadata storage server software. So you can use these alerts and metrics which are inbuilt into Exadata storage server software to monitor Exadata storage server, only storage server. Okay, only storage server. Underline this. So every Exadata storage server installation creates something called a metric and alert repository. Every Exadata storage server system is pre-configured to generate alerts. It has inbuilt metrics which are monitored. Each metric has a predefined threshold by Oracle. Okay, you can see all those metrics, their current thresholds. Even you can change the thresholds as per your requirements. And once Exadata storage server is started, it will populate these metrics. And once a metric crosses a specific threshold, it will generate alerts. And these alerts can be forwarded to the admins through emails or SNMP notifications to a centralized monitoring tool like Oracle Enterprise Manager, where you can see these alerts in the dashboard of the graphical tool. So that is one very helpful feature of Exadata storage server. Every Exadata storage server has inbuilt alert and metric repository with the predefined metrics which generates alerts when certain metric crosses the threshold or when some failure happens within the storage server. For example, if any hard disk fails, okay, it will automatically generate an alert. You can get that alert to your inbox, email inbox. So that is the concept. So every Exadata storage server is delivered with inbuilt alert and metric repository, which can be used to monitor that particular Exadata storage server. What about database servers? You have to use your traditional method like shell scripts or any other tools for database servers. What about switches? Okay, you have to use again any other third-party mechanism or scripts. So that way, if you don't have enterprise manager, you have to look out for different ways of monitoring different components. Only thing is, storage server, you don't need to depend on third party. You don't need to write any shell scripts because storage server is delivered with the inbuilt monitoring mechanism. Metrics which continuously monitor internal instrumentation of the storage server, generate alerts, and you can receive alerts. So all this mechanism is inbuilt into storage server. But you have other components, database servers, switches, power distribution units. So you have to find out a mechanism to monitor them. For database servers as a DBA, traditionally we use shell scripts, other third-party monitoring tools, homegrown tools, okay, whatever you have, you can continue to use them to monitor database servers. But only thing now is how do you monitor the InfiniBand switches, Cisco Ethernet switch, power distribution units. So you have to find out a ways for that. Okay. So if you don't want to take all that pain, different monitoring techniques, different components and all that, the single easy integrated solution is Oracle Enterprise Manager Cloud Control. In fact, most of the Exadata customers use Cloud Control. That is a simple, easy, okay, uh, way to monitor Exadata platform. Only thing is you have to purchase, license, install, configure, and start using that. So unfortunately, in the lab environment, we cannot deploy cloud control because technically that is a technical problem. You can actually install it, that's not a problem, but it will not discover any components of Exadata except database servers in the lab environment, because we know we are in a virtual environment. We don't have a real storage server, right? Real hardware is not there. And we don't have InfiniBand switches. We don't have Cisco Ethernet switch. We don't have power distribution units. So it cannot detect those targets. You can install technically, you can install, that's not a problem. But after installing, you have to deploy agent software. That also can be done. You can deploy agent software on the database servers. Okay. And the third step is we have to discover the targets. Okay. Exadata targets like database servers, storage servers, switches, InfiniBand switches, Ethernet switch, power distribution units, and all these things. So that task will fail because we don't have real components, real hardware components. It cannot detect them and fail at that stage only. So at the max, what you can do in the lab environment, you can deploy agent software on the database servers and monitor database servers. So it is as good as monitoring your regular database servers. Okay. So that's the reason why we are not using Enterprise Manager in the lab environment. But in real time, many customers may use Enterprise Manager. So you become familiar with Enterprise Manager if you are not already familiar, or if you are already familiar with Enterprise Manager, you just need to know how to monitor Exadata specific targets. So what I can do, I have some documentation on how to use Enterprise Manager to monitor Exadata platform, step-by-step documentation. I will share that documentation with all of you. So when you are working in real environments and using Enterprise Manager, you can go through that documentation, become familiar with Exadata specific monitoring techniques, and start monitoring your Exadata platform. So in the lab environment, we use the inbuilt monitoring mechanism, which is metric and alert repository. Okay, not Enterprise Manager. Oh,
One small doubt.
yeah.
The volume also monitoring for storage servers.
Yes, you use. See, that is Enterprise Manager can be used to monitor everything inside Exadata, including storage servers, switches, power distribution units, apart from database servers.
Okay.
So that is the single monitoring tool which can monitor all components of Exadata. There is no other tool which can do, okay, the same kind of monitoring. So Enterprise Manager is the only tool for Exadata. Maybe in future, uh, okay, you might find some third-party tools. As of now, there is no third-party tool to replace Enterprise Manager when it comes to Exadata. Okay, so this slide shows you uh, the Enterprise Manager deployment architecture. Even though we are not doing this in the lab, just for your understanding, knowledge purpose, I'm going to explain how enterprise manager is deployed, and the typical architecture, deployment architecture. Okay. Now, in this slide, we have database machine Exadata system on the left side, which has all the components. Okay. You have basically the database servers. This is database server, and this is storage server. Apart from database servers and storage servers, we have components, other components. InfiniBand switch, Ethernet switch, KVM switch, then power distribution units. So you have other components also. Now we have installed Enterprise Manager on a different system. Yes. Suggested mechanism is you deploy Enterprise Manager on a non-Exadata system separate from Exadata. And you know the Enterprise Manager has three primary components: the management service, OMS, right, which is the application, then Enterprise Manager repository, which is an Oracle database, and the Cloud Control Console, which is the GUI application. And once you install Cloud Control, you need to deploy agent software on the targets, right? Now, when it comes to Exadata, agent software is deployed only on the database servers. You don't deploy agent softwares on the remaining targets. Okay. Normally speaking, we have to deploy agent software on every target that should be monitored using Enterprise Manager. But when it comes to Exadata, the agent software is deployed only on database servers. You should never ever install agent software on the storage server. For that matter, you should never ever install any kind of software on the storage server. Okay? If you do so, Oracle will not support your configuration, including Enterprise Manager agent software. You should not install. So that way, storage server is like a black box. You should not tweak it. You use it the way Oracle ships it. If you do any kind of customizations, modifications, okay, that configuration will not be supported. Now, agent software is deployed with Exadata plugin. Okay, so you can see this is the management agent, Oracle management agent, this green portion, right? And it also includes Exadata specific plugin. This is the Exadata plugin. So on Exadata platforms, you need to deploy agent software on database servers only. And this agent software should be deployed with Exadata plugin, which extends the agent functionality, agent software functionality to monitor Exadata specific components. So this plugin extends the agent functionality, basic functionality, to monitor Exadata specific components like storage servers, InfiniBand switches, Ethernet switch, KVM switch, power distribution units. Without this plugin, this agent software can monitor only the local targets on the database servers like database instance, ASM instance, listener, clusterware components, operating system, okay, and ILAM interface. ILAM also another component actually. So Exadata plugin extends the agent software capability to monitor Exadata specific targets. So that is what you need to understand. So we deploy agent software with Exadata plugin. Now let us see how it works. Now this agent software, management agent, OMA, okay, can monitor the local targets deployed on the database server. The local targets on the database server include these ones: the database instance, yes, the local targets include the database instance, ASM instance, listeners, clusterware, and the OS information, and ILAM interface. Every database server also has ILAM. Actually, this ILAM interface is not monitored directly by agent. It is through the plugin again. Without plugin, you can monitor only the local targets, these targets. That's it. Now, how do you monitor other targets? That is through Exadata plugin. Now you see Exadata plugin has a dotted line relation with other components. Now Exadata plugin, basically on the storage server you have two main components, MS and the cell server, management server and the cell server. Okay, so Exadata plugin communicates with the other components using SNMP. Okay, SNMP. So on every component, SNMP is supported. On every Exadata component, SNMP protocol is installed. SNMP based communication is supported. Similarly, the plugin can communicate with InfiniBand switches, monitor InfiniBand switches, Cisco Ethernet switch. So you see all these dotted lines. And the ILAM interface on the database server, power distribution units. You can even monitor your power distribution units through Enterprise Manager, which supplies the power to the rack. There are redundant power distribution units. You can monitor them, how they are working, if any problem, everything graphically through the Enterprise Manager. So that way, this Exadata plugin communicates with other components using SNMP traps. SNMP is the default protocol installed on every component inside Exadata. So, and because this is SNMP trap, the collected information can be propagated to an SNMP based tool like Oracle Enterprise Manager, where you can see all the information in the centralized console. So this is how the agent is deployed, and it is used to monitor the local targets and the other targets present on other components. So this is the Enterprise Manager deployment architecture. Anyway, we are not using this in the lab environment. In the lab environment, we learn how to use the inbuilt mechanism, which is inbuilt into Exadata storage server. Okay, monitoring Exadata storage servers using cell metrics, alerts, and active requests. Okay, as I told you, Exadata storage server has inbuilt alert and metric repository. Okay, which is used by the administrators to monitor Exadata storage servers. Now you know the terms metric, alerts, these are all well known to DBA, right? So metrics, alerts, and active requests. Metrics and alerts help you to monitor Exadata storage server. Active requests provides a view of client IO requests that are currently being processed by a cell. Active request is if you are running an IO request on the cell, it is shown as an active request. If there are no IO requests currently being processed, then there are no active requests. Okay, so when you are running a long IO request on the storage server, you can query the active request information. It will show you how much of IO is completed, how much of pending, okay, at what rate IO is being transferred. Okay, all those details will be listed to you. If there is no IO request going on, it will not show anything. That is the active request. Active request is currently ongoing IO requests on the storage server. Metric and alerts, you know, every DBA would know what is metric and what is alert. Now, before going deeper into this, let us recap this slide. Okay, rewind your earlier learning. We have seen this slide in earlier. Okay, in earlier session, in one of the earlier session. Now, on Exadata cell, you have disks, right? You have disks. Disk 0, disk 1, disk 11. Total 12 disks. You know, on the first two disks, there is something called a system area. Okay? System area, a small amount of disk space is used for system area. This system area is present only on the first two disks. And these system areas are mirrored using Linux LVM, so that the system area is available on both the disks. Even if one disk fails, you have the system area on other disk. What is this system area? This system area is where operating system binaries, cell storage server binaries, alert and metric repository is installed. Yes. So you observe this. This system area is where OS binaries, cell software, that is Exadata storage server software, and alert and metric repository is created. This system area size is 29.125 GB, which are mirrored, right? Then on the remaining days, an equal amount of disk space is used for DBFSDG on the remaining 10 disks. Okay, so that way you can understand the alert and metric repository is inbuilt in Exadata. When you install Exadata storage server software, it automatically installs the alert and metric repository, which uses space. That space is from the system area, right? Now this slide is metric, some points related to metrics. You know, metrics are recorded observations. Metrics are associated with objects like a cell days, grid days, IORM, okay, IORM plan. Okay, like that, there are many objects used by storage server, and every object has metrics which are used to monitor that object. These metrics are computed and retained in memory initially for an interval of time, and at fixed intervals, the metric details are persisted to disk. Initially, they are captured in the memory, and a snapshot of these metrics is taken on hourly basis and persisted to the repository which is on the disk. Okay, so metric values can cause alerts to trigger. So every metric has some threshold. You can set up those thresholds, and basically warning threshold, critical threshold, right? So warning is when it reaches to certain level. Critical is when it reaches to very critical level. Suppose a table space usage, you know, just for example, we are monitoring table space usage through some metric in the database. So you can set up warning message. Suppose when the table space usage reaches 70%, it can generate warning threshold. That is warning threshold. Okay, first time alert. Then you didn't act on that. You didn't fix that issue. Now it reaches 90%. Now you get another alert. You can set up another notification. That is critical threshold. Now it is very critical. You have to act. Otherwise, you may face problem. So that way, for every metric, you can define warning threshold and critical threshold. In fact, for all the metrics inbuilt into Exadata storage server, there are warning and critical thresholds. Oracle has defined warning and critical thresholds. You can see all those metrics and warning thresholds, critical thresholds associated with each metric, and you can even customize them, and you can define your own metrics also. In fact, Oracle has that API. So normally we don't do all these things. We don't even customize because most of the settings are pre-configured by Oracle and optimized for Exadata environments. So under rare circumstances, you may want to change their setting values. Then alerts. Okay, alerts are typically propagated to monitoring infrastructure such as Oracle Enterprise Manager or notified to the storage administrators using email notifications. So you can configure storage servers to send email notifications. If you remember, you have already done this. Okay, in one of the hands-on practice, you configured storage server to send email notifications. Fictitious email setup we have done. Okay, so during installation of Exadata, you can input emails which should receive the alerts from the storage servers. Later also, any time you can configure Exadata storage server to send email notifications. Okay, the alerts will be sent through email notifications. And alerts, you can probably configure 3 types of alerts: warning alert, which is associated with warning threshold; critical alert, which is associated with critical threshold; informational alert, okay, which is just for information sake. Suppose now critical threshold is reached 90%, you get a alert associated with critical threshold. Now you fixed it again, it came back to normal 50% utilization. Now you will get another alert saying that you don't need to worry now, it is under normal usage. That is just informational alert. So you can have 3 types of alerts: warning alert, critical alert, and informational alert. So that is alert. Having understood the meaning of metric, alert, and all that, now let us see the inbuilt metric and alert repository architecture, how it works. Okay, this is all inbuilt. You don't need to do anything. We are understanding the architecture of the metric and alert repository, how these alerts are gathered, where are those stored, and how they are persisted to disk and all that. Now, basically you have cell. Yes. So this is your storage server, cell. Now cell has 2 primary components, cell server and MS. Cell server, earlier you learned cell server collects metrics. MS also collects metrics. Yes, that is inbuilt. You don't need to do anything special. Okay. So once you install Exadata storage server software, it starts collecting various metrics automatically. And these collected metrics are related to various objects like cell disk, grid disk, IORM, interconnect, flash cache, flash log. So you know Exadata storage server has many objects and metrics are collected for different objects. These metrics are initially collected in the memory, okay, of the storage server. So once the metrics are collected, every now and then, at every interval, fixed interval of 1 hour, default is 1 hour, okay, every 1 hour these metrics, a snapshot of this metrics is taken and persisted to the alert and metric repository, which is on the disk, so a snapshot is taken and persisted to the disk. So it sounds similar to your AWR for the database server, right? So AWR metrics also similar, right? They are collected in the memory, and every 1 hour a snapshot is taken and persisted to AWR repository. So the same concept here also. Next, you have MS, okay, management server, which also collects various other metrics apart from those collected by cell server. And MS also scans the diagnostic data, all the log files, trace files are generated, and checks for any error conditions reported in the log files, any internal errors. And apart from that, MS also detects any hardware and software failures inside the storage server. You see, any software errors, any hardware issues are detected by MS, and alerts are generated and notified to the administrators. So here, who sends alerts? Once alert is generated, who sends alerts? Management server. Management server. Cell server doesn't forward those alerts. Okay, alerts are handled by management server. Remember this. Okay, you learned this earlier also. All the alerts generated will be forwarded to the clients, recipients by MS. So this is how the alert and metric repository architecture, okay, looks like. Now you can use various commands, basically list command, to see all the metrics, to see all the alerts, their definitions, their current values, current settings, and history of metrics. Okay, list metric history, list alert history, and once the metrics are persisted to the repository, in the repository they will be there for a default time of 7 days. Every 7 days these metrics will be purged. So that 7 days time is the default. You can increase, decrease, you can see all these settings, okay, and change these settings as per your specific requirements. Now, having understood the architecture, let us see how to display all these metrics. I want to see all the metrics inbuilt into Exadata storage server. So basically you use a list command. Okay, any display we use a list command. You can display metric definitions, the current metrics, metric history, and the metrics are related to various objects like a cell, cell disk, grid disk, flash cache, flash log, etc. Yes, you can increase. Okay, you can increase that using alter cell command. I will show you otherwise on the storage server. Let me connect to VPN. I will provide your account today, Vijayanand. Okay, today you will receive your login details. Earlier you installed VPN, right? Or you want me to send a VPN software also? Yeah, if it is there, I will send you the login details today, server login details. Yeah, no problem. Yeah, you will get it. By afternoon, you will get it. Now let me connect to one of the server, probably 100, the first one. Now I connected to database server. Let me associate to the storage server. Now once you are on the storage server, you can start a cell client. Okay, and use list cell detail command. This will display various attributes of the cell object. You can see one of the attribute is metric history days. Default is 7. Notification method mail. notification policy, critical warning clear. And this cell has been configured to send email notifications. Okay, in the lab in earlier classes, we have practiced this, how to set up storage server for sending email notifications. Suppose you want to change the metric history days from 7 to 14. You can simply say alter cell, okay, metric history days 7, okay, something like this, alter cell this attribute. That's it. So now if you see, it should show you 14. It is as simple as that. You want to change email anytime, just to change these attributes. Now Bruce Lee is receiving, instead of Bruce Lee, you want to receive. You put your email ID by using alter command. So it is as simple as that. Okay, now the real meat, how to display all these metrics, and for each metric, how to see the definition. The current metrics means which are currently being gathered, current values of the metrics, history of the metrics which are gathered over the last 1 week time, which are available in the metric repository. So we use a list metric definition to display the definition of all the metrics defined by Oracle. Okay, and you can use list metric definition on a particular metric if you know that metric, and you can use that. And you can use a list metric definition where object type equal to gradient. So you can display metrics related to a particular object type. Okay, and you can display current metrics, the current values of all these metrics at this moment, and list metric history, historical, okay, collection of the metrics which are available in the repository. So let me show you list metric definition. This command will show you all the metrics defined by Oracle. Okay, these are all the metric names. Not many, okay, you will have around 40-50 metrics, okay, defined in the storage server, not more than that. So it will give you only names. If you want a detailed information, you can just add a detail. Now you see, for every metric, it is displaying more information. Name of the metric, okay, description, a brief description of that metric, metric type, cumulative, instantaneous, rate, something like that, object type. So this metric is related to which object, unit of measure. Okay, so that way for every metric you can see the definition. Okay, you can see the definition, and you can use list metric definition for a particular metric. Suppose CL CPUT, cell CP utilization, that is the metric, I know that's name. Or let us take, you can use anything. Suppose this is the metric, now you know its name, right? I want to display only for this. If you know the metric name, you can just simply mention that name. So it will display information about only that metric. Okay, so that way you can display all the metrics, a particular metric, and you can display metric related to a particular object. You know, metrics are associated with objects. Suppose list metric definition where object type equal to cell disk. So these are the metrics related to only cell disk type object. See, they start with the CD. CD indicates the cell disk. CD. So the metric name has some meaning. So the first the first word is CD. CD indicates cell days. So like that, if you see these metric definitions, list metric definition. GD means grid disk. These are the metrics associated with grid disk. N means network. Okay. N means network. IORM. This is related to IORM. And FC, flash cache related metrics. FL, flash log related metrics. So like that, you can easily identify the metrics by looking at their names, whether they are related to cell disk, okay, and grid disks, or okay, flash cache, flash log, interconnect, anything like that. That is how Oracle named that. Now you can use a list metric current command, list metric current. It will show you the current values of all these metrics. Whatever 50, 60 metrics we saw now, we listed now, it will show you the current values of these metrics. At this moment, what is its value? Okay. So by querying these metrics, you can observe the values and understand the health of your storage server. You can continuously monitor these values every now and then and monitor the storage server performance. Suppose I know one metric. I want to monitor CPU on the storage server. Okay. List metric, current metric. Sorry, metric current. CL CPUT. Currently, what is the CPU utilization? 6%. Okay. Similarly, metric current CL MEMUT, memory utilization. Now, currently memory utilization is 90%. So that way, from CellCli, you can use these metrics, you can query these metrics, and understand how your storage server is performing. You can use them to monitor your storage server usage, performance, and all that. That is how they help you. So by continuously monitoring these metrics, we can monitor the storage server. Only thing is, you need to understand the meaning of each metric, how it helps you to monitor various things. So Oracle has guides, right? PDFs, and they explain about all these metrics. What is this metric, the definition, more detailed information in the Exadata storage server user guide. If you want to learn all these metrics, the meanings, okay, no need to master all of them, but if you want, you can refer to Oracle user guide, Exadata storage server user guide, which is available on OTN. Like database has metrics, right? Database has various metrics. So that way storage server has all these metrics. Now, not only this, these are all current metrics. I can list the history. List metric history. Okay, the history of the metrics which are available in the repository. So it will display the metrics from the repository, whatever are available in the repository. Default is 7 days, right? So this may display long, information, lengthy information, metrics collected over the last 7 days. Okay. Now you see, it's a very lengthy, long display. It is getting all these from the metric repository now. So if your metric repository retention time is 14 days, as we said, it will display the metrics collected in the last 14 days. You are observing? So this is a lengthy, long, list. So I'm stopping this, Control C. No, it stopped and came out because I pressed Control C. Okay, so you got the good idea now how to use these metrics, display, okay, and all that. Now next, alerts. Yes. Next, let us play with alerts. Again, you can use a list command to see all the alerts and alert definitions. You can display alerts from the repository, all the alerts generated so far, a particular alert using list command, which is similar to what we have done now. You can say list alert definition. It will show you all the alerts that are defined by Oracle. Like metrics, there are predefined alerts. Okay, there are predefined alerts. Again, there are very few alerts, not hundreds of or thousands of alerts, only 40-50 alerts. So in every new version, Oracle may add more alerts, more metrics, okay, but they are not very big. The list is small. So that is how you display all the alerts. Now you can display detailed information. Alert definition detail. Like metrics, detailed information. Okay, like metric, detailed information. Detail. You can display particular attributes like this. List alert definition attributes. Okay, like suppose these are all the attributes, right, which are displayed. You can display particular attributes. Suppose I want to display attribute and say alert description. You can do that. Okay, only name and description. Type. Okay, type is not the attribute. Alert type. Alert type. Sorry. Alert. So that way you can display whatever attributes you want to display. Similarly, you can see all the alerts currently generated which are available in the repository. List alert history. Now you see on the storage server, we already have some alerts. Okay, we already have many alerts. Now every alert will have a unique ID. This is that ID 4_1. Okay, and then the timestamp, what type of alert, and what is the message. Then the second alert, timestamp, what type of alert, and the message. Then the next alert, 13. Okay, again 14, 15, 16, 17, 18, 19. So like that, you could see there are around 8 to 10 alerts on this server. Okay. Now you see the last alert, one of these alert, you can go through that. What is this alert? 19, which was generated on 12th September, right? At this time, it is critical alert. What is the message? RS 7445 server. Cell serve is absent. So that time cell server was shut down. Okay, and you see it will be restarted. Who is restarting? RS. RS will automatically restart cell serve. So internally, when some abnormal condition happens, it automatically generates alerts. You can list these alerts and see what is happening and all that. Suppose you see this alert, this is big alert, 12:01, so and so, okay. Warning, hard disk entered confinement status, confined online status, okay, some big message. This alert is generated when the disk performance is below normal. Most of the time in the lab environment, alert type, sorry, alert. So that way you can display whatever attributes you want to display. Similarly, you can see all the alerts currently generated which are available in the repository. List alert history. Now you see on the storage server, we already have some alerts. Okay, we already have many alerts. Now every alert will have a unique ID. This is that ID 4_1. Okay, and then the timestamp, what type of alert, and what is the message. Then the second alert, timestamp, what type of alert, and the message. Then the next alert, 13. Okay, again 14, 15, 16, 17, 18, 19. So like that, you could see there are around 8 to 10 alerts on this server. Okay. Now you see the last alert, one of these alert, you can go through that. What is this alert? 19, which was generated on 12th of September, right? At this time, it is critical alert. What is the message? RS 7445 server self-serve is absent. So that time self-server was shut down. Okay, and you see it will be restarted. Who is restarting? RS. RS will automatically restart self-serve. So internally, when some abnormal condition happens, it automatically generates alerts. You can list these alerts and see what is happening and all that. Suppose you see this alert, this is big alert, 12:01, so and so, okay. Warning, hard disk entered confinement status, confined online status, okay, some big message. This alert is generated when the disk performance is below normal. Most of the time in the lab environment, many times you will see this kind of alerts, because in the lab environment we have only one physical disk and created many virtual disks. So when the system is under heavy load, you see these kind of alerts generated. Hard disk performance will be below normal, very less. So that way you can list all the alerts. And you can list a particular alert by mentioning the alert ID. Suppose I want to list only alert ID with 19. So it will display only that alert instead of displaying all the alerts. Now active requests. The third one is active requests. Active request is what? If currently any IO is going on, it will show you the details about that IO. If there is no IO, okay, it will not display anything. Okay, suppose I am typing list active requests. Now what is happening? No display. What does that mean? There is no IO happening on this storage server. If any IO is happening, it will show you the details about that IO, the IO rate, how much is completed, how much is pending. So you will get an idea how long it will take to complete this IO request, and the transfer rate, that is another use of that. So if there are no active IO requests, it will not show you anything. So these are all the examples which I showed you. Okay. So this is how you use the inbuilt alert and metric repository to query all these details, to understand the performance of your storage server, and to monitor various aspects of your storage server. Now, third-party monitoring tools. If you want to use any third-party monitoring tools, what is the guideline? Okay. Installing any additional software on storage servers is not supported. You should never ever install any other software on storage server. Storage servers, can be configured to send alerts to SNMP subscriber. If you have any SNMP based tools like Oracle Enterprise Manager, you need to configure SNMP subscription to send the alerts to the SNMP tool. Other than that, you should never ever install any software on the storage server. So you can practice. We have more commands in the lab environment, in the lab material. Whatever we discussed, you can practice that. Only one practice for today's topic: monitoring Exadata storage server with the metrics, alert, and activity. Hands-on 29. Whatever I showed you, many of them and even more commands are there in the material. Just to follow that, practice these commands, observe. Okay. So you can become familiar with how to use all these things. Any doubt? Yeah. Now we have some other tools which are used frequently on Exadata. Okay, which helps the DBAs to monitor, to work with Oracle support. These tools are DBA friends. Okay, they are friends of the administrators. They help you to manage, monitor Exadata environments, and especially when you are working with Oracle support, these tools will come in handy. So let us see the other useful tools on Exadata platform. There are many tools, and this slide shows you the main important tools which are useful. ExaCheck, Diag tools, ADRCI, Image Info, Image History, OS Watcher, ExaWatcher. Okay, so in each new version, Oracle is adding more and more tools. Okay, like now you have ExaClay, ExaDClay, DBMClay. So there are other tools also available, but these are some of the very important core tools. Okay, so out of all these tools, I would say ExaCheck, the first one, is the most important tool. Every Exadata DBA uses this, and that is the most important tool for Exadata DBS. So what is this tool and what are the other tools? Let us quickly go through them. Some of these tools works only on real hardware. Unfortunately, this important tool ExaCheck works only on the real Exadata server. It will not work in the lab environment, in virtual environment where there are no physical components, real components. Okay. So let us talk about ExaCheck. What is ExaCheck? ExaCheck is health check utility for Exadata environments. Health check utility for Exadata environments. It is something similar to your VeraCheck for non-Exadata environments. I hope you heard about VeraCheck and used VeraCheck. Yes? Yeah, many DBAs would know this. Earlier we had a rack check. Okay, now VeraCheck is the health check utility for non-Exadata platforms. So it is similar to that one. ExaCheck is for Exadata environments. So it allows you to collect information about every component of Exadata. Okay, every component of Exadata. And it also includes best practice recommendations. Okay, and your compliance score. Okay, how many best practices you implemented, and gives you a scorecard report of that. And for every component, it will show you detailed information. What is that component? What is the software, firmware, the versions, any patches are available. If you have applied any patches, what patches are applied. So it is very, very detailed report. It collects the data regarding database machine component versions and best practices. Pre-installed on Exadata-based machines, and Oracle continuously refines this tool. You can download the latest ExaCheck utility from this MOS note 10.70954.1. So this is the note MOS note, My Oracle Support note, where you can download the latest ExaCheck utility. And Oracle highly recommends you to run ExaCheck utility on regular basis, on periodic basis, every 1 month. Okay, as a best practice, you need to run ExaCheck utility every month, and that is recommended. Not only monthly, whenever you are making important changes to your system, before making the change, you run ExaCheck. After making the change, you run ExaCheck. Compare these two reports and see if there is any deviation for any of the component. Suppose you are applying patch today. Patching is a big activity, right? So before patching, run an ExaCheck report. Take the report. That is the baseline report. Good report, healthy report, right? When the system is healthy before patching. Now you apply patch. After patching, again you generate the report. Now you compare this report with the baseline report and see if any component has any deviations from the baseline report. So that way, ExaCheck is highly used utility, highly used tool, highly recommended tool. Every Exadata DBA uses this. There is no exception to this. And you can run on a monthly basis. And in between also, whenever you need, whenever you are making any changes, okay, important changes, configuration changes, patching, upgrading, anything that you want to do, you can do. But before and after that change, you better run ExaCheck. It doesn't make any changes to the system settings. Okay, it is a non-intrusive tool. It doesn't make any changes. It just gathers the information, and it is also very lightweight, and it does not impact the system performance. It runs for certain time. When you run, it is ad hoc. It is not a continuous monitoring tool like Oracle Enterprise Manager, right? And it cannot be a replacement for Enterprise Manager. Both are complementary. And it is not a continuous monitoring tool. Whenever you run, it runs for certain amount of time, maybe 1 hour, 2 hours, based on the size of your rack, number of components present in the rack. After that, it terminates. So that way, it will not generate a continuous load on the system and has minimal impact. So it checks many things on the system and various components of the system. These checks are these are the main checks, but many other checks will be performed. So from disk to database, everything is okay. Every component information is gathered. Operating system information, kernel parameters, okay. Oracle database software installed, patches installed, Exadata software installed, their versions, okay, and firmware versions, disk group, ASM disk group information, database parameters information, clusterware parameters information, okay, alerts generated, InfiniBand switch configurations, maximum availability architecture, okay, compliance. So almost everything about your system and components. It is pre-installed on every Exadata system, and the latest tool can be downloaded, okay, from MOS. This slide shows you how to do that. You can download this zip, exacheck.zip, to a database server and unzip this, and inside you will have shell script exacheck. You just need to run this exacheck utility, okay, and it will start and initially ask the passwords of various components that it need to gather the information about. And once you type the passwords of all these components, it runs in the background, collects all the information, which may take 1 or 2 hours or 3 hours depending on the rack size, and generates a detailed report, HTML report, which is similar to your AWR report for your database. Yes, so we have AWR report for the database. So ExaCheck report is similar to that. It is not just a database, it is for entire Exadata system. So this is how it looks like. You can go through the report, various sections, hyperlinks are there. You can click and go through and understand that the report. I have some reports collected from projects. I will show you real reports, small reports on small systems, okay, recently collected from one of the Australia client. Okay. Where did I store them? Yeah. So here you can see this report. Okay. This is how it looks like. This is a small report. This is in fact a quarter rack system, small system, not a very lengthy report. But if it is full rack system, the report will be really very, very lengthy. So system health score 98 out of 100. So this system is very healthy system. Okay, it conforms to all the best practices, all the recommendations are implemented, all the patches are applied, all the versions are current. Okay, so that is what it verifies. It verifies your system health, component health, and gives you a score, okay, to indicate whether your system is managed in a healthy fashion or it is deviating from the current versions, current patches, or any other best practice recommendations. And it has these many sections: database servers, storage servers, InfiniBand switches, cluster-wide infrastructure, Golden Gate, findings that need further review. Okay, it will show you any findings, abnormal findings that need a review. Okay, so it will tell you where you need to focus. Here you see one review, one finding is there: warning OS check. Key InfiniBand fabric error counters should not be present. Okay, details view. So it found something and alerting you, so that you can focus on this and fix that. So that way it will give you what to do, the description, detailed description of that this thing, the risk associated with that, the action, the repair. Okay, what you need to do to fix that. Okay, and once you fix that, the expected output should be success. Key InfiniBand error counter were not found. So that way it will even recommend you what to do. Okay. Now ExaCheck can be configured as a daemon because you need to run every month or every now and then. You can configure it to automatically run. So you can schedule it as a daemon. So it has a daemon capability. You can schedule it. So this command shows you how to schedule it as a daemon. ExaCheck. Okay. You will mention the schedule, auto run schedule. Okay. So this is the scheduling. This is something like a cron tab scheduling. Only difference is the minute field will not be there. The minute field will not be there. So otherwise it is cron tab scheduling, similar to cron tab scheduling. And once the ExaCheck is run, you can type the email so that the alert will be, the report will be mailed to your email. And for this, I am giving some ID, Monday run or monthly run or okay, any name to identify your ExaCheck run. So then once like that, you may configure the daemon to automatically run, okay, on a fixed date and time. Every month, first night at 10 o'clock, 10 p.m. Okay, this is actually every Monday at 10 p.m. So weekly run. Monday, yeah, this is Monday run, right? Even ID is also named as Monday run. So every Monday it runs at 10 p.m. So you can see all the daemons, their details. You can stop the daemon. You can see the status of the daemon, next run, when it is going to run. So that way you can schedule the daemon, ExaCheck daemon, to run automatically. That is the overview of ExaCheck. Next tool is Diag tool. Diag tools are used when you are working with Oracle support. Otherwise, you don't use them. Okay. So, you know, when you work with Oracle support for any issue resolution, they will ask you to upload a lot of information. You upload a trace file, alert file, that file, this file. Okay. So, on Exadata, you have many components. You have many files to upload. Manually gathering all these files becomes very manually gathering various log files, trace files, which are required by Oracle support, may be challenging. So that is where Exa tools are helpful. They help you to gather all the files required by Oracle support. You just run them. They will gather all the files on your system. Just upload these files to Oracle support. So it comes in a GIF format. You can download from MOS. Again, this is the MOS node 735323.1. Okay, latest version of Diag tools will be available here. You can download them and unzip that. Once you unzip that, it contains two shell scripts: diag-get.sh, dbmcheck.sh. So you run these shell scripts. Diag-get.sh, okay, collects Oracle software logs and trace files, plus operating system information from all the servers, database servers and storage servers. Then next script, dbmcheck.sh, collects information about storage servers. Okay, so when you are working with Oracle support, you depend on these scripts, which gathers the information required for Oracle support. So that way you don't need to go back and forth. They will ask one file, again you have to gather. Next time, after some time, again they will ask another file. So that is not required. Just these Diag tools automates the Diag collection. Then ADR/CI. You can use ADR/CI to collect the diagnostic information also. ADR is inbuilt on Exadata storage server. If you don't want to use diag tools and all that, you still have inbuilt diag collection, diag monitoring tools, right? So in earlier classes, we learned Exadata storage server also uses ADR. It has diagnostic data which is stored inside ADR, automatic diagnostic repository. So you have ADR/CI utility to manage the diagnostic data, to collect the diagnostic data, to view the diagnostic data. So if you are familiar with ADR/CI and database, you can use that knowledge to manage diagnostic data on storage servers also. Okay. Then image info, image history. These are two important commands, okay, two important utilities which we frequently use in real time, okay, on the real servers. Again, they work, these utilities are loaded at a factory by Oracle during server installation, operating system installation. So these utilities are not available even for download, okay. They come with only real Exadata servers. So on Exadata, Oracle follows imaging process to install the software. So Exadata software is installed as an image. Okay, every update is installed as an image. So you are applying a patch, it is applied as a image. Okay, so Exadata storage server patches are also provided as images. So whenever you are applying a patch, you are installing a new image. A new image includes operating system, new version of Exadata storage server, and updates to the Exadata storage server. You don't apply the patches to the existing image. Instead, you install a complete image, which includes OS binaries, Exadata storage server binaries. So at any point in time, you can use image info to display information about the current image installed on the servers. And over a period of time, you may have multiple images. As you install new image, you will have old images also, right? So image history shows you history of all the images installed on your servers. Okay, so how to use them? Just type image info. Image info will show you the current image information, the latest image installed on the Exadata servers and its information. Suppose you see image information shows you the kernel version, OS kernel version, and Exadata image version. Exadata image version is 12.1.2.21, so on. Image activated, on which date and time this image was activated. Okay, and some other partition information in which this image is installed. So when you come to backup and recovery, you will learn more about this. Okay, this is very interesting thing done on Exadata, which requires you to understand the disk layout also when it comes to backup recovery, patching topics. Tomorrow, day after tomorrow, we will see them. Then image, okay, this is on the storage server. Same image info command, this is on the storage server. Okay, then image history. History of all the images installed on the servers. Now this shows you three images. Okay, this shows you three images installed on the server, old and new. Okay, all the images installed so far on the server. So if you have access to the real servers, you can simply type these commands. Okay, it will show you your Exadata image versions installed currently on your servers. And if you have installed new images, you can use image history to see all the images installed so far. Then OS Watcher, also used on Exadata. You know OS Watcher is familiar to most of the DBS. It is not Exadata specific tool, right? OS Watcher can be used on non-Exadata platforms also. It is OS Watcher is bunch of shell scripts which collects OS information, operating system information. So most of the time, a DBA needs OS information also while troubleshooting any hang issue, performance problem, or reboot issues. Even Oracle support requires that. So how do you gather OS information? That is done through OS Watcher, which is a bunch of shell scripts. Okay. By default, OS Watcher is installed on all the Exadata servers. You don't need to install that. It comes with the pre-installed, pre-configured, and the default installation location is opt oracle.oswatcher osw. This is the fixed directory. Then OS Watcher collects OS data and archives that in the repository. This is that repository location, opt oracle.oswatcher.osw /archive. And if you want to know more details about OS Watcher, this is the MOS node 301137.1. I am not sure if you have used OS Watcher or currently using. This is not specific to Exadata. You can use on any database platform. Now, actually, nowadays, if you see the latest versions of Exadata, Oracle is not using OS Watcher. Initial versions of Exadata used OS Watcher, but quickly Oracle realized OS Watcher is not sufficient for Exadata platforms. We need more than OS Watcher. We need Exadata specific OS Watcher. That is where Oracle introduced Exa Watcher with 11.233 version of Exadata storage server. So if you are on the latest versions, anything above 11.233 version, you don't find OS Watcher. Instead, you find Exa Watcher, which is Exadata specific version of OS Watcher. Replaces OS Watcher, bunch of shell scripts which collects OS data, installed on all the servers by default, located under opt oracle.exawatcher directory. So this is the installation directory. If you have access to the servers, you can go to this directory and you can see Exawatcher under this. Okay, information gathered will be archived in the archive directory. This is the archive directory, opt/oracle.exawatcher/archive. So how to use this? Okay, if you are not familiar with Exawatcher or OS Watcher, this is the MOS node. It has its own documentation, how to use, how to gather the information. Okay, see, I will show you. Yeah, that brings us to the end of the session today. I will show you some OS Watcher reports that we collected in projects. Okay, and I used to give monthly report to the customers, which also includes OS Watcher reports. Okay.
Mostly Exadata is inbuilt, or we have to install the software?
No. It is pre-installed. It just replaces OS Watcher. It is installed by Oracle.
Okay.
So I should have many reports. I just want to show to you how they look and delivery. No.
Yeah, it's there. OS Watcher graphic scripts, no? So
Yeah, this is one monthly technical report we submitted to customers. Okay. So this report includes exhaustive information. Okay. And in this report, this you see, these are OS Watcher reports. These graphs, CPU utilization, these are generated by OS Watcher. Okay. These are on the database servers. So we have 80 database servers. And the memory utilization similarly. This is again coming from OS Watcher, these graphs, these details. So OS Watcher collects the OS data, generate graphs, okay, which are useful to you to embed in any other reports, or you can analyze them standalone. Okay, so like that you can use okay, OS Watcher reports. Fine, you got some idea now? Any question? So if no question, that's it for today. Tomorrow we'll see the next